Ako pagka okay na ha. Hello, magandang umaga po mga kawerpa. Good day to everybody. Good day all over the world. Okay, who are listening to us in YouTube live stream and to our friends, no, for those people or students, no, who are watching our presentation for today. So, good morning, everybody. So, my name is Engineer Reggie Marinay of Powerhouse Review and Training Center, the Marinay's Powerhouse Team Review and Training Center. Good day to everyone. So this is a free lecture on YouTube live stream. We are a review and training center of electrical engineering in the Philippines. So we are happy to say that we are the only review and training center maybe in the world doing this kind of lecture wherein we have a discussion of, in a detailed discussion of basically all the topics in electrical engineering, no? And also, we'll be discussing some special topics as we go along. So this is a very detailed discussion on electrical engineering. So good day, everyone. So we have some participants. So there is this is an interactive type of lecture or way. So we are doing some recording. So this is for today. This is a live lecture. So I hope that you will bear with us. So please bear with us, especially to our non-Filipino friends who are watching right now. We are trying our best to speak the English language, no? Although I'm not fluent to speak that language. So we just have an intention to help the students, the electrical students in particular, around the globe. So how we wish that we have 1,000 participants for each day so that we would have so many people, especially this time of pandemic. So education is very expensive. But now, we'll just give this lecture for free to everyone. So this is one of the advocacy of our review and training center to make some lecture on YouTube, and we will try our best. The basic or the what do you call this, the fundamentals, no? Well, actually, not only the fundamentals, no, from basic to advanced topics, we will give you that, no, for free. So this is part of our advocacy to help everyone, especially this time of pandemic. We are the only review and training center doing this kind of activities wherein the student may ask question as we go along. To our student, you may ask question for each and every question or item being discussed. Pwede kayong magtaas ng kamay ninyo dyan. Okay, mga kawerpa, mga kababayan kong Pilipino, ha? Kung may tanong kayo, after every number, no? O kaya, 2 numbers, you may ask question. Okay? This will be an interactive class type. This is how we will do sa aming review program. No? Ganito ang gagawin namin sa mga reviewees na mag-e-enroll sa amin, yung setup, magiging ganito po yung setup. No? And we are proud to say that we are the only review center doing this kind of activities. So this is not easy. This is a very hard task for us. And we are apologizing for some flaws, no, for some sablay, no? You know sablay? Ano ba sa English yung sablay? So we have some shortcomings, no? While we are doing this activity, this lecture on a live stream. So actually, we have no editing on this presentation. We are not doing editing because up to now, we don't know how to edit. Okay, so let us, for further ado, okay, so let us continue our discussion. Actually, I already started my discussion about the parallel circuits. Now we will discuss the continuation. Okay, let's start. We are on number 10 actually. We have a bundled question, 10 to 16. Two batteries are connected in parallel. So, given E1, 6.4 volts, R1, 0.006 ohms, E2, 6.3 volts, R2, 0.005 ohms, supplies current to 0.3 ohm load resistance. So, let us draw the figure, the given. Okay, let us write down the choice, the given for E1. Our E1 is 6.4 volts. Then our E2 is 6.3 volts. Then R1 is 0.006 ohm. Then R2 is 0.005 ohm. So we have a load resistance of 0.3 ohm. 0.3 ohm. Okay, so that is the given values. That is the given. So for number 10, again, this is just the continuation of our lecture last time. So for number 10, so find E total. So what is our E total? So let us have first our currents here. I will call this current as I1. This is our I sub 2. And let's say this is our I total. I total. That is our total current. Okay, let us have our working formula. So, at this node, let's say at node A, we will make use of by Kirchhoff current law. What is Kirchhoff current law, by the way? Kirchhoff current law states that the summation of the current around any node is equal to 0. The current entering is positive, so we have I1 plus I2. And the current leaving is negative. So, the current leaving at node A is I total. So, that is minus I total, so that is equal to 0. Okay, then we have here I1 plus I2 will be equal to I total. I'll just put here our total current. That is our total current. Okay, let us just transpose this one. It's just simply mean that the current entering is always equal to the current leaving at a particular junction or a node. So, by Ohm's law, so what do we have here? So, we have, by Ohm's law, we have the voltage. Since this is total, so E total over R total, that is equal to E1 over R1 plus we have E sub 2 over R sub 2. Okay, now we have our R total. So we have our E total over. Then remember we have our R total. What is our R total? Simply our R1. Okay. We have our R1. There are two resistance in parallel here. That is the product over the sum. So we have R1 times R2 all over R1 plus R2. Okay? So that is our total resistance. So we have here our E sub 1 over R1. Okay? I will represent this as small R1. Okay? Then plus we have E sub 2 over R sub 2. Okay? So, let us solve this, simplify the equation algebraically. So, meaning, we have here for ET, we have here our ET over 1. Okay? Did you remember the extremes over the means? So, this is the extreme. Okay? Over the means. Okay, so we have here our R1. We have R1 plus R2 multiplied by E total, then over R1 times R2. So that is equal to, we have E1 over R1. And then we have plus E sub 2 over R2. Now, let us multiply both sides by the product over the sum. So the product over the sum is, we have R1 times R2 over R1 plus R2. Okay, let us multiply this equation here. Okay, so what will happen, guys? This will cancel out. R1 times R2 will cancel, and also the R1 plus R2 will cancel. So, what will be left is our E sub t. No? E sub t, this one, right? Okay? Okay, everybody in our Zoom class, please open your camera so that you will be considered as in our attendance. Okay, so we have here our E sub t that is equal to, what will happen here for our E sub 1? E sub 1, okay? Then multiply the product over the sum. So what will happen here? Remember that we have R1 here. we have R1 times R2, so R1 will cancel out. Okay, so this will be our equation. So E1, okay, so cancel ang ating R1. Ano matitira? We have R2 over R1 plus R2. Okay, what about now for E sub 2? Let us cross multiply this here for E sub 2. The R2 will cancel out, right? So we have here E sub 2, okay, E sub 2 then multiplied by R1. Okay, we have R1 plus R sub 2. Okay, let us substitute all the given. Our E total will be, what is E sub 1? 6.4. 6.4 volts. E sub 1. R sub 2. R sub 2 is 0.005. R1, 0.006 plus 0.005. Okay. And then plus, we have E sub 2, which is 6.3. Then multiplied by R1, 0.006 over 0.006 plus 0.005. Okay? So just manipulate this. What will be our total answer? Our answer here. Let us use our calculator to solve this. Okay, my final answer here is 6.345. 345 volts. That is my final answer. Okay, what letter is our answer, please? On our PowerPoint. What letter? There you are. Okay? The answer is letter C. Then let's go to number 11. So number 11 is easy. So the question is, what is our total resistance? So our total resistance simply equal to the product over the sum. R1 times R2 over R1 plus R2. That is the formula for two resistances in parallel. Okay? So, maybe we can just go directly with our calculator. Okay? Just give me the final value. Okay? 0.006 times 0.005 divided by 0.011. Product over the sum. Okay, my answer here is 2.72 times 10 to the negative 3. What shall we do here? So if this is to the negative 3, we will move the decimal places 3 times to the left. Okay, so we have here the decimal point 1, 2, 3. Okay? So therefore, our answer will be, so we have 0, this is the decimal point, then we have to put 2 zeros here, 1, 2, then we have 2, 7, 2 ohms. Okay? In our choices, that is nearest to what letter? Okay. Okay. The answer is letter A. Letter A. 0.003. Find the total current delivered. Okay, for number 12, okay, the total current being delivered, let us draw the equivalent circuit. So this is the equivalent circuit. This is our E total, then R total, then we have our load resistance. We have here our total current, okay? Then if we want to get our load voltage, it's somewhere here. That is the voltage across the load resistor R. Okay? Then, we are asked to find here the total current delivered. Okay? The total current is just by Ohm's law. Total current is equal to the total voltage. What is the total voltage? E total. Okay? That is our ET. Then over our load resistance R plus RT. All values are already calculated. Let us just substitute the value we calculated for number 10 and 11. Our ET is 6.345. 6.345. Our R is 0.3. Then plus, okay, let's make use of 0.00272. 0.00272. What is our total current? $6.345, then divided by the sum of 0.3 plus 0.00272, then equals. The answer is 20.96 amperes. Okay, what letter do we have here? 20.96 is nearest to? Okay, that is letter B. Okay, dog. That is our answer. Okay, any questions so far? Will you raise your hand? Pakita natin sila. Nakita sila? O, taas ang kamay. Sino may tanong so far? Meron? Wala? O, sige, babalik tayo mamaya sa inyo, ha? Okay, tuloy natin. Number 13. Find the load voltage. So, this is easy. Load voltage. So, let's say we have a voltmeter. We have the voltmeter that is the voltage measured to the load. In the load, so we have our, take a look here, our load voltage. Let's say there is a voltmeter here. It's simply I total multiplied by the load resistance. So we just have to substitute. Actually, we already have the value. I will just go directly in my calculator. 20.96, then multiplied by 0.3. So, my answer here is 6.288 volts. Okay? That is our answer. Nearest to what letter? Okay? 6.288 is letter B. Okay, guys? Did you get that? Okay, let's go with number 14. So before I go to number 14, I will discuss some basic principles about the circulating current. Okay, actually what we are doing is the circulatory current method. This is what we call the circulating current method or circulatory current method in the other books. Okay, take a look here. Again, to our question. We have here two batteries. Then we will introduce here a switch. Okay, so this switch, okay, I will open the switch. If we open the switch, there will be a circulating current in the direction of the higher voltage. What do I mean? In here, we have our E sub 1 is greater than E sub 2. So therefore, our circulating current is on a clockwise direction. Because this is 6.4, 6.3, this has a higher voltage. A higher voltage. Okay, conventionally, the current, again, just like I discussed before in our electrical principles, conventionally and externally, the current will flow from positive to negative. Shall we say on a clockwise direction. Now, if we open the switch, this is what we call the circulating current or circulatory current. What is the formula for circulating current? Okay, for number 14. The circulating current simply equal to E1 minus E2 all over the sum of the resistances. So we have R1 plus R2. Okay? So, the higher voltage minus the lower voltage divided by the total resistance around a loop because this will form a single loop. Right? That will form a single loop. So, this is the basic formula. Okay? Actually, we are not yet in Kirchhoff's laws. I just showed to you the Kirchhoff current law. But the voltage law, that will be our next topic, no? Probably for next week. I will discuss those network theorems. Okay? So, what is the bigger voltage? We have 6.4 minus 6.3 minus 6.3. Then, if we are to add the two resistances, that will come up to be 0.011 ohm. Because 0.06 and 0.05, 0.011. Okay? And then, what is the value here? Let us solve. 6.4, okay, then minus 6.3 equals, then divided by 0.011 equals. Our circulating current is 9.091. 9.091 amperes. Okay? So that would be letter. There you are. Okay? Letter D. Okay, let's continue, guys. This is find the current supplied by E1. The current supplied by E1 is our I1. Okay? So what will be our I1? By circulating current method, we will have a current divider theorem. By current divider theorem. What is current divider theorem? I will introduce here I1 prime. This is not actually the actual current. Let us have first our I1 prime. That is equal to the total current multiplied by what is the current divider theorem. take a look here. That will be the current flowing if the switch is open. That will be the current flowing in our E sub 1. Okay? We can, if that is open, the switch is open, we can call this as I1 prime and I2 prime. Okay? So, that's equal to the total current multiplied by the opposite resistance, which is R2. Which is R2 over R1 plus R2. Okay? And then we have our I sub 2 prime. That is also equal to IT. That is the current in our E sub 2 multiplied by, that is IT multiplied by the opposite resistance, which is R1 over R1 plus R2. So let us substitute. What is our I total? That is 20.96. And then, multiplied by R2, R2 is 0.005. Then R1 plus R2 is 0.011. Okay? So let us calculate. So we have 20.96 then times 0.005 then divided by 0.011 equals. So the answer is 9.527. 9.527. Okay, 527. Or that is 9.53. Okay, for 2 decimal places. What about here for I2 prime? So we have 20.96 then multiplied by our R1 is 0.006 actually. That is 6. Then over the sum 0.011. Okay? So what is the answer? 20.96 times 0.006 divided by 0.011 equals. The answer is 11.43 amperes. Okay. Remember this current divider theorem that the switch is open. The switch is open. Now, let us find the actual current. Find the actual current. Or shall we say, find I1, I2. Here. I1 and I2. Find the actual currents. So, what is our I1 and I2? What is our I1 and I2? Okay, so we have here our I1 prime. That is the same direction as I1 prime. Actually, I2 is the same direction as I2 prime also. This is a little difference in terms of the circulating current. If the circulating current, take a look here. We have I1 prime here. That is also the direction of I1. Yun din yun. Parehas yun. If the circulating current has the same direction of the current, I1 prime, they have the same direction. This is clockwise. So this is going up and this is also going up. Okay? They are both going up. Meaning they assist or help each other. So we have to add I1 prime with circulating current I sub C. For I sub 2, take a look for I sub 2. The I sub 2 is going up and I sub C is going down. So they have a different direction. This is going up, the I2 prime, the IC is going down. So let us subtract. If they have different direction, you subtract I sub C. Okay. From the given values we have, let us go directly with our calculator. What is I1 prime? I1 prime is 9.53. And then plus the circulating current of 9.09. Approximately, our answer here is 18.62. What about for our I2? That is equal to I2 prime, which is 11.43. 11.43. And then minus our IC. Our IC is 9.09. That is equal to 2.34. Okay. So that will be our values for I1 and for our I2. Let's take a look here for our I1. We have 18.62 nearest to letter C. That is 18.61. What about for number 16? Okay, 2.34. That is nearest to letter A. Here. Okay? So that will be for number 15 and 16. Okay, guys? Okay, so we are finished with batteries. Any question, everyone? Any question? Raise your hand. Gallery view mo, net. O, baka may tanong kayo, mga kawerpa. So far, taas ang kamay. Sir Leo, may tanong? Wala. Okay lang, thumbs up kung wala. Naintindihan? Okay, Sir Garcia. Question. Okay, kung wala, thumbs up lang. Joshua, wala ka na. Paki-open lang po ang inyong mga camera. Paki-open po. Pangit pong tignan. Hindi po magandang tignan ng mga titingin sa YouTube. Mga kawerpa, pakiayos po ang ating mga setting. Sino ba si Galaxy? Sir, pakilagay po. Hindi po kayo makakuha ng certificate kung hindi po kayo susunod sa policy. Put your name and your school. Ulitin ko po. Leo, paki-ano po. Ayos. Nickname muna una, tapos dash. O, parang yung ginawa ni Joshua. Ganyan lang po kasimple. Joshua dash UST. Ganun lang po kasimple, mga sir. Sunod po tayo, mga sir. No? Marami pong nakamonitor sa akin. Pati yung aking mga business partner, nakamonitor kung sumusunod ako sa kanilang pinag-uutos. Okay. Ayan, o. Ngayon natin nalaman, may taga-TIP pala rito. Hindi tayo nakakapunta dyan, eh. Sa TIP. Philip, paki-open nga ang iyong camera. Everybody, paki-open po ang camera. Antayin namin kayo. Sige po, antayin namin kayo. Paki-open yung camera. To our non-Filipino friends, so please bear with us. So this is a live stream and this is an interactive, a classroom type of lecture or presentation. You will see this in YouTube. We will upload this afternoon, right after this presentation. Okay, let us continue, guys. Let us continue. Okay, we are finished with parallel circuit. We will now go to the combination of the series and parallel circuit. Okay, let's have number 1. A substation supplies a factory 229 meters away with powers as follows. We have two motors taking 40 amps and 60 amps respectively, and 200 pieces of 600 or 60 watts lamps. The load voltage is 200 volts if the loss of power in the leads is not to exceed 5% of the power supplied. Take the resistivity as 1.7 micro-ohm centimeter. Find the total power loss. Okay, that is the question. Let's go over with our circuit. That is a series parallel circuit actually. This is the supply leads from the source. There is a certain resistance. Okay. Then we have here two motors being supplied. Let's say we have motor 1. We have motor number 2. Okay, they are connected in parallel. Okay, then we have a lamps. How many lamps do we have here? There are 200 pieces of lamps. So let us draw the 200 pieces of lamps. Here, okay. I only have 3 here. Let's wait for 197. Okay. Okay. So I already drew the 200 lamps. Let's say this is the 200 turn. This is the first lamp and this is the 200 lamp. Okay. Okay, that is a DC system like the Edison system, the Thomas Edison system. This is the resistance of the wire. Okay. So let's say we have here our I1, we have I2. This is our total current. And this is our total voltage. Okay? So the distance from substation to the factory is 229 meters. We have a voltage, the load voltage of 200 volts. This is the 200 volts at this point and to this point. Okay? The voltage in the motor and the lamps. Okay, so let us get first our I1. Take note that there are motors, 40 and 60 amperes. Okay, to calculate for our I sub 1, that is simply equal to 40 plus 60. So we'll come up with how much? 100 amperes. What about for our I2? Current is basically power divided by the voltage. This is our I2. We have P2 over B2. What is our P2? What is our total power across the lamps? We have 200 pieces. Then times how many watts per lamp? 60 watts. So what is V sub 2? Of course, that is also 200. Why? Because they're just in parallel. The lamps are connected in parallel with the motors. So what is our I sub 2? Well, anyway, there's a cancellation there. So that is only 60 amperes. Okay? So we can solve now easily for the total current. Simply equal to I1 plus I2. I1 is 100, I2 is 60, so we have 160 amperes. Okay? The question is, find the total power loss. We have to get first the total power. What is our total power? That's equal to V total multiplied by I total. What is V total? The load voltage, 200 times 160. So what is the total power? $32,000. 32,000 watts. That is the total power. So in our problem, it says that our power loss. So we have if the loss of power, the power loss, that is equal to 5% of the supplied voltage. So meaning that is 5%, that is 0.05, right? So 1, 2, that is 5% multiplied by the total power. So therefore, the power loss simply equal to 0.05, then multiplied by, we have 32,000 watts. So therefore, our power loss would be equal to 1,600. Okay, that is our final answer. 1,600 watts. And that is letter B. Okay? Then follow-up question. Find the resistance of the wires. Remember that the power loss that is equal to I squared R, resistance of the wire. We have 1,600 watts that is equal to, what is our total current? The R wire is this, the resistance at the leads. Okay? This is actually our I total. What is our I total? 160 squared, then R of the wire. What is R of the wire? 16. So the answer would be 0.0625. Okay, the answer would be letter. What's our answer here? There you are. Okay? So that is letter C. Okay, for number 3, find the area of the wires in square centimeter. The area of the wire. Okay, so we have the resistance of the wire that is equal to rho L over the area. So, the resistance of the wire will be, the resistivity is given. What is our resistivity? 1.7 times 10 raised to negative 6. Okay, that is micro. Rho times the length. What will be our length? 229 meters. That is given. Remember, this is rho centimeter. Then multiplied by the length, which is 229 meters times 100 centimeter per meter. Okay? And then we have to divide it by the area of the wire. That is the cross-sectional area. Okay? And remember that the resistance of the wire is, this resistance is 0.0625. Okay? So just manipulate what is now the area of the wire in square centimeter. Okay, the answer here is 0.62. Okay, our unit will be what now? This is cancel. Okay, of course, this is ohms, cancel out. Centimeter square is our unit. Or square centimeter, I mean. Okay? Okay. This is square centimeter. By the way, if we have square centimeter, square centimeter, is that equal to centimeter squared? Let's say if you have 1 square centimeter, is that equal to 1 centimeter square? Are they equal? Okay? What is 1 square centimeter? Just like this one. Okay, I will make this as 0.62 centimeter. Or as we read this as 0.62 square centimeter. Now, is that equal to 0.62 centimeter square? Are they equal? Let's go first with 1 square centimeter and 1 centimeter square. Okay. What do we mean by 1 square centimeter? That is already the area. Is that necessarily a square? No. It can be a rectangle. We have here, it can be a circle. It can be a circle. 1 square centimeter. That is the area, that is the cross-sectional area of any shape. But if you mean 1 centimeter square, is that an area? No. That is a square that has a sides of 1 cm here and 1 cm here. Did you see the difference? Okay. Again, What is 0.62 here? We calculated. That is the area of the conductor, which is a circle. 0.62 square centimeter. But what is 0.62 centimeter square? It is a square that has a side of 0.62 centimeter. 0.62 centimeter here. 0.62 by 0.62. If we want to get the area, multiply 0.62 by 0.62. Did you get that? Did you get that? Is that clear? Is that clear? Okay, let's go on to the next number. Find the voltage at the substation. What is the voltage at the substation? That is actually our E sub T. For number 4, that is our E sub T. What is that? E sub T, okay? Did you remember the powerhouse chop-chop law? Okay? I introduced to you our theorem. That is actually the son of the Kirchhoff's voltage law. That is by the powerhouse, that is the name of our center, chop-chop law. Let us introduce this to the world. Okay? So, the powerhouse chop-chop law. Okay. What is powerhouse chop-chop law? Okay? Once again, my friend. Okay? The voltage here plus voltage here is equal to the voltage here. Remember, our voltage at the source is our E sub T. So, this is our E sub T. That is equal to the load voltage, which is 200 volts. Plus, okay, let us represent the 200 so that it will be easier for you. That is the load voltage, V sub L here. Please show this. VL plus the I total, that is resistance of the wire. Okay. So, we have here E total, that is equal to VL. What is our VL? 200 plus I total, 160, multiplied by resistance of the wire, 0.0625. E total will be equal to what now? $210 volts. Okay, that is the answer. That would be letter D. Okay? Ito yung voltage sa substation, mga kawerpa. No? Source voltage yan. That is the source voltage. Sir, why you did not multiply it by 2? Because there is RW on the upper portion and on the lower portion. Well, actually, this RW is the RW here is represented the upper portion and the lower portion. Okay? The upper portion here and the lower portion already. Because we computed here from the power loss, so the RW now represents the resistance on the upper portion plus the lower portion. Okay? Well, if we want to be more meticulous, we can put here R1, W1, and W2. So that if we are to get RW is RW1 plus RW2. That is the exact. Okay? We have to consider the upper portion and the lower portion because there are two conductors. Okay? So, let us continue our problem solving. Number 5. Okay, we have a nice question here. We have a figure. Find the resistance of the circuit shown. Take a look here. This is a combination of series and parallel circuit. For number 5, parang maaga tayong matatapos. Okay, sige. So, nandito na tayo. Anyway, I will give my own example if we still have time. I will create a problem on the board. Okay. So, find the resistance of the circuit shown. Take a look here at our circuit. Okay? I will not draw this anymore. I will just draw the equivalent circuit. Take a look here. What can you say about the 4 ohm and 4 ohm here? They are in parallel, right? What we have studied before, if we have two resistors, no, two identical resistors in parallel, that is simply equal to the branch resistance over the number of branches. Okay? So, what do I mean? I will get the resistance here. I can say that is the resistance at BC. Because if this is point C, take a look. This is a network analysis. If this is point C, this is also point C, right? Because that is just a short circuit. This portion, this point and this point is just one. They're just the same. So, I will represent this as RBC. What is our RBC equal to? Okay. What is the branch resistance? 4 ohm, because they are identical. Put here 4. How many branches do we have? 1, 2. So, 4 over 2. Dominate calculator. Okay. So, that is also 2 ohms. Okay? Okay. I will make it step by step. I will solve this into in a very detailed manner. So, we have here a resistance of 3 ohms and this is already the 2 ohm equivalent. This is the one we calculated here. So, this is our 3 ohms. Okay. So, we have our point C here. Let's say this is our point A here. So, we have a 10 ohm below. We have 10 ohm here. And on the upper portion, we have, this is 10 ohms. On the upper portion, we have 2 ohms. We have 2 ohms here. Okay? There you are. 2 ohms. Okay. And then, find the resistance of the circuit shown. What do you mean by find the resistance? Or that is the equivalent resistance or the total resistance. What do we mean by that? If we are to put a source here, this is our point A and point C. And this is our point B. Remember that let us impress a voltage source E here. Okay? Let us impress. If the voltage, we call this as impress. If we mean current, we mean injected. That is injected in the circuit. Okay. So, what is our voltage impressed? Well, we don't need that. There's no given here. What I'm trying to say here is, if we are to get the equivalent circuit or the total circuit, it simply means, if we are to replace this voltage source by an ohmmeter, okay, I will replace this. That is actually the resistance across the source. If we are to remove the source, this will be our total resistance or equivalent resistance, or the resistance at point A and C, basically. So take a look, guys. What is 3 plus 2? Calculator. Okay. Do not depend too much on your calculator. No? So 3 plus 2, 6. That's wrong. Okay. So we have here 5 ohm. Okay. So 3 plus 2. Okay. Now, if we have 2, we have 5, we have 10 ohms. Now, we are ready to solve. This is easy. According to the formula, So this is 1 over 1 over 2 plus 1 over here. This is the 2, this is the 5 plus 1 over 10. Okay? Then using our calculator, we can set up this easily. Just use our calculator, this symbol that is below the calc button. Okay? This symbol is a fraction. Let's call this as a fraction symbol. That is our button, the fraction. Okay? And then you just have to use your replay button here, your arrow left, right, up, down button. Okay? The biggest button in your calculator. So, let us press first our 1, then our fraction, then 1, then over, press arrow down, then press 1, fraction, 1 half. Okay? If I say 1 half, press 1, then you press the fraction, and then 2. Then arrow right, then we have here 1 over. If I say over, you have to press your fraction. 1 over 5, then arrow right, then plus 1 over 10. Okay, that would be equal to 1.25. Okay, so this is 1.25 ohms. Okay. So our answer would be, what is our answer here? Letter C. Okay? Got it, guys? Nakakuha po ba? Makaka-aware pa? Nakasunod? Okay. Let us go over with find the resistance of the circuit shown. Take a look here. Take a look. Okay, for number 6, we can see here, we have CD. Take a look. This is point C and point D. So these are identical resistors in parallel. So this is easy now. Let us get our RCD. Our RCD, it will be equal to what? What is the branch resistance? We have 12. So that is 12. 1, 2, 3. There are 3 branches. So 12 over 3, so we have 4 ohms. 4 ohms. Now, let us have now the resistance here at B and C. What is RBC? Our RBC is 2 parallel resistors. They are not identical. So therefore, we can solve this by the product over the sum. Product over the sum. So that is 2 times 4. Over 2 plus 4. Okay? So we have here 2 times 4 divided by 6. So that will be 1.33. Or we can make use this as a fraction. That will be 2 times 4. So we have here 8 over 6. Divided by 2. 4 divided by 2. So we have 3. So we have here 4/3. No? 4/3. Now, let us get, remember that we already have RBC and CD. Okay? Okay, I will draw first so that you may get this. So, this is, let's say, our point A. That is our point A. Then we have a resistance here. Okay? And then, let's say this is our point D. Take a look at our BC, okay? That our BC, we have a resistance 2 and 4, which is the equivalent of BC. BC is 4/3. 4/3 here. Remember, this is B and C. This is 4/3. 4/3. And then there is equivalent circuit here of what? Take a look again. We have 3 12-ohm resistors, which is 4 ohms. Okay? Then we have here our point D. Okay. Between the 3 ohm resistance here is from B going to D. BD. Okay? There you are. So this is 3 ohms. Okay? And then the upper portion. What about the resistance from A going to D? A going to D, so we have here 16 ohm resistance. From A to B, take a look here. From A to B, we have 2.08. Okay? So these are all the ohmic values. Okay, now, let us consider these two, because these two are connected in series, these two. So we just have to add 4/3 and 4, right? Are you getting me? Pakita nga natin yung ating mga audience. Nakakasunod ba? Joshua of UST, nakakasunod ba? Okay. Sir Leo, nakakasunod? Okay. Sir Garcia? Okay. So, we just have to add 4/3, 4/3. Okay. They are in series, so let us add. Okay? 4/3 plus 4 equals. That is 16/3. Okay, the equivalent of 4/3 and 4 is 16/3. Remember, there will be one resistor here that has a value of 16/3. This will be combined to only one resistor. Now, we can get the value of this. There will be two parallel branch here. Okay? Let us call this as BD. What is the resistance across point B to D? Okay? So we have 16/3. There will be two resistors here, 1 and 2. So we have 16/3. Okay? Then multiplied by 3. Then divided by 16/3. Then arrow right plus 3. That is just the product over the sum. So we'll come up with 48 over 25. Okay, I will just make this as a fraction, 48 over 25. Okay? So we'll come up with a single resistor here. Do not look yet here. Do not look. Just look these two branches. We have 2 branches. We have 16 over 3. The equivalent of these 2 resistance is in parallel with this 3 ohm resistance. Okay? Nakakuha? Nakaparallel tong 16 thirds dito sa 3 ohms. Let us continue here. Okay, so we have here the 2.08 ohm resistor. Then we will be having here a single resistance here. So this is point A. So we have point B. We have point D. Then we have 2.0 ohm at 2.08 ohm resistance. And then we have the 16 ohm resistance here. Connected on A going to B. This is 16 ohms, guys, no? Okay. 2.08. What about this? What is the equivalent here? 48 over 25, no? The RBD. 48 over 25. That is the value. Now, to get the equivalent resistance, so let's say again, we have a voltage source here. Let us replace the voltage source by an ohmmeter to measure the resistance. Again, what can you say about these 2 resistors? They are connected in series. Okay, for you to understand this easily, let us have the equivalent value. What is 2.08? So 2.08 plus 48 over 25. The answer is 4. Simply 4. This is from point A going to point D. And then we have a 16 ohm resistance. Remember that the answer must be less than 4. If you have in the choices greater than 4, that's already wrong. In calculating parallel circuit, the equivalent resistance is always lower than the smallest branch resistance. Okay? So this is our total resistance. So this is now easy. We have an ohmmeter here. So the total resistance now will be 16 times 4 over 16 plus 4. So, what would be our final answer? 16 times 4, then divided by 16. And Anyway, we can make it 20. 16 plus 4, that's 20. Okay. 3.2 is our final answer. And that will be letter. What letter is this? Okay, there you are. That's very easy. Okay, very easy. Okay, next number 7. Uy, what about? What happened? That's a curtain. Anong ginawa ni Angie dyan? Okay. So, in series parallel circuits shown, find the voltage across the 4 ohm resistor. Remember that we have 24, 12, and 8 ohm here. We have 10 and 8. There is a voltage here. 50 volts. And remember that the 50 volts here is equal to the voltage drop at the 10 ohm resistance because they are just simply connected in parallel. Always remember in circuit analysis, if you have a straight line that is just equivalent to a dot, always remember that. Okay? That a line is just equivalent to a dot. That is for the circuit analysis. Okay? Always remember that. Okay? So, let us get first our current here. This is simply by Ohm's law, right? That is by Ohm's law. So, we have, for number 7, what is the voltage of the current? What is the current flowing in 8 ohm resistor? By Ohm's law, we have 50 volts divided by 8 ohms. Okay? So, we have 50 divided by 8. That is 6.25. 6.25 amperes. Now, take a look here, guys. These two are connected in parallel, right? And these 3 are connected in parallel also. These 3. Remember, the line is just equivalent to a dot. This is a node. This is also a node. Okay? Now, let us get this one. There is a 6.25 ampere flowing here. Okay? Tingin mabuti ha. Kung 6.25 ampere ang dumadaloy dito, meron tayong kuryente dito. We have a current here of 10, we will calculate that. Okay? And we have these 3 resistances. Now, let us make use of the current divider theorem. Let us call this as I. Let's call this as I1. The I in the 8 ohm resistance. Let us call this as I1. They are equal. I1 is equal to the current in the 8 ohm resistance. And then let us name the current here as I total. By current divider theorem, I1 simply equal to the total current multiplied by the opposite resistance. If this is our I1, what is the opposite resistance? The opposite resistance is 10 ohms. All over 10 plus, so this is 10 plus 8 ohms. Okay. So, we already have a value for I1 that is 6.25. So, just shift solve this, no? Let us solve this. This will become 10. So 10 plus 8, we have here 18. Okay? So just solve this. So cross multiply, that is 6.25 times 18, then divided by 10. And that is equal to 11.25. So the total current now is 11.25 amperes. Okay? Ampere. Okay? I watched in the YouTube, the teacher called this as ampere. The 12 ampere. Okay. 11.25. That is the current flowing in the 4 ohm resistance. Then the question, sir, is find the voltage across the 4 ohm resistance. If I have a voltmeter here, let's say I am a voltmeter, okay? I am a voltmeter, see? Show them. That letter B, okay? I am a voltmeter. I will measure this. What is the voltage here? The voltage across the 4 ohm resistance. The 4 ohm resistance is simply equal to the current, which is 11.25 times, of course, the 4 ohm resistance. So the answer would be 11.25 times 4, 45 volts. That's the answer. Okay, the answer would be letter, what letter? Letter C. Okay? Letter C is the answer. Follow-up question. There is a follow-up question here. In the series parallel circuit shown, actually they have the same circuit. Find the supply voltage B. Where is the supply voltage? Always, that is connected in the 2 points across all the resistances. Okay? The 2 resistances, these resistances, this circuit is connected to a battery. There is a supply voltage here. So find the supply voltage. Find the supply voltage. Okay. I want to get the equivalent resistance of these 3. Okay? I want to get these 3. So, let's say our resistance in our 8 parallel with 12 parallel with 24. Okay, so we have 1 over 8 plus 1 over 12 plus 1 over 24. So that is equal to what? Let us solve this. 1 over 8 plus 1 over 12 plus 1 over 24 equals. The answer is 4. Simply 4. Okay, take a look here. I will draw the equivalent circuit. We have a 4 ohm resistance here. Okay. And then, we have here, take a look here, again, this line is just equivalent to a dot. Let's say this is the dot. Okay? We can have the equivalent of 10 and 8 ohm. Remember, for the 8, 12, and 24, the value is 4. Definitely, the equivalent of these three resistances in parallel, we have to know that the equivalent resistance of these three resistors is always less than the smallest resistor. Meaning, the equivalent resistance is less than 8. Ang equivalent resistance nitong tatlong ito, mga ka-aware pa ha, tatagalugin ko. Hindi pala, imposible pala matagalog na pure yun. Tatlo ito, okay? Ang makukuha mong equivalent na resistance, mas mababa sa 8. Nakuha? Okay? So, okay, I am getting the resistance for 8 and 10. 8 parallel with 10. Or simply, product over the sum. 8 times 10 over 8 plus 10. Okay? 8 times 10, that is 80, then divided by 18. So the answer is 4.44. Or, in fraction, that is 40 over 9. 40 over 9 ohm. So this is the 40 over 9. So we have here as 4. Okay? Now, what is the equivalent of the three resistances? The three resistances has 4 ohm also. Okay. Actually, our total current is already known. That is 11.25. That is our total current. So we can easily get our total voltage. What is our total voltage? Here. Let us add all the three resistances because they are just now connected in series, right? Right, left? Right. Okay. So, we have 4 plus 40 over 9 plus 4 equals. The answer is 12.44. Or in fraction, this is 112 over 9. 112 over 9 ohm. Okay? What about the total voltage? The total voltage. What is the total voltage? So we have I total times R total. So what is I total? 11.25. There you are. Okay, multiplied by 112 over 9. So therefore, our total voltage is 140 volts. 140 volts. That is our total voltage. Okay? Okay guys, that's letter D. Okay, let's go on to number 9 here. A 12 ohm resistor is connected in parallel with a series combination of 16 ohm and 8 ohms resistance. If the drop across the 8 ohm resistor is 48 volts, determine the total current. Again, so a 12 ohm resistor is connected in parallel with a series connection. So we have here this is what we call a parallel series circuit. Okay, so we have a 12 ohm resistor. We have 16 ohm resistor here. We have 8 ohm resistor. If the drop across the 8 ohm resistor is 48 volts, determine the total current. This is the total current. Okay? This is the given. We can calculate now for the current here. Let's say this is our I1. Because the current flowing in the 8 ohm resistor is also the current flowing in the 16 ohm resistor. Because they're just connected in series, right? So, we can easily calculate our I sub 1. I1 simply equal to 48, that is by Ohm's law, 48 over 8. What is 48 over 8? Okay, 48 over 8, 48 over 8. 48 over 8, that is actually 6. See, I'm not good in mathematics. Even this, I just have to use my calculator. You don't have to be great in mathematics if you want to become an engineer. That's what I am saying before. Okay? Sometimes in the licensure exam, 2 plus 8. I have to use, even my professor who is a third placer, Engineer Francis Karagatan, he said that to us when he got the third place. You know, in the licensure exam, no? Even a simple addition, you have to use your calculus. Although, of course, you know that already, but you want to make it sure. You really want to make it sure because the licensure exam is your future. If you pass the board, the licensure exam, you'll become an engineer. Okay? Of course, you will earn better if you are a licensed compared to unlicensed. You can have a bigger salary. That is your hope. Although, of course, we are not disregarding those people who has no license. It depends still on the person, on the people, how you use your craft or your skill. Okay? I know somebody is not even a college graduate, but he is a very rich person. Many people I know, even the famous one. No? Okay. So, 48 over 8. Calcu. 6. Okay? So, we have here 6 amps. Again, we can make use of by current divider theorem. What is the current divider theorem? Again, our I1 simply equal to I total multiplied by the opposite resistance. What is the opposite resistance of I1? Yung katapat, opposite, 12 ohm. All over 12, then plus. What is the sum of this? 16 plus 8. Okay, that is 24, right? 24, are you sure? Yes, okay. 24. Okay. So, I1 is simply 6 ampere. Okay, 6 amperes. Okay, just manipulate this. This is easy now. Okay, so we have the current 6, then cross multiply. So, times 12 plus 24. Then divided by 12, the answer is 18. You see, you just have to be a math enthusiast if you want to become an engineer. You don't have to be great in mathematics, no. Me, I'm just an average student in mathematics, no? I just excel in a major subject, no, in electrical engineering during our licensure exam. So, but I'm not, I didn't have a very high grade in mathematics. So, our total current now is 18 amps. Okay. I just had my highest grade is in electrical engineering major subjects. Okay. Let's solve now number 10 problem. Pang ilan ba ito? Pang ilan? Okay, number 10. So, two resistors A and B are connected in series across 120 volt source. When 30,000 ohm voltmeter is connected across A and then B. The instrument deflection is 48 volts in each case. What are the ohmic values of the resistor? Listen, I consider this as a difficult category because it needs a deeper analysis. Okay? So let us analyze the circuit. Two resistors are connected in series. Okay, so we have two resistors in series. 1, 2. Are connected in series across 120 volt source. When the 30 ohm voltmeter is connected across A and B, the instrument deflection is 48 volts in each case. Let us connect first our voltmeter to resistor A. Because the instrument deflection is 48 volts. There is a voltmeter here. Of course, this is resistor A, resistor B. There is a voltmeter here. And the reading of the voltmeter is 48 volts. Okay? Now, we have here a current flowing. Shall we say this is our IA? Okay? Please focus here. This is our IA and this is our IB. And this is I of the voltmeter. I victory. Okay? By Kirchhoff current law, the current entering is equal to the current leaving. Okay? So, we have IB, okay? IB plus IA is equal to I sub B. Okay? What is our IB equal to? Ohm's law. What is the voltage across the voltmeter? Of course, that is just 48 volts. Over. What is the resistance? Voltage over resistance. The resistance is 30,000. Then what is our IA? Remember that the voltmeter and the resistor are in parallel. They have the same voltage, 48. And then we have the resistance, just simply RA. What about now for our IB? What is the voltage across the resistance B? Okay. We have 120 volts, the total voltage here. We have just to subtract 48 to 120. 120, okay? What's the time now? It's already 11:20. 11:20. Okay. So, 120, parang ngungo, ano? 120. Okay. So, minus 48, ba? Okay? That is the voltage in the RB over RB. Okay? Let us arrange now. By the way, what is 120 minus 48? You see, I have to use my calculator before okay? 72. So this is 72. 72. Okay, let us arrange now our equation. 48 over RA. Let us transpose this minus accept natin. May pumapasok pa. Okay. So, 72 transpose 72 over what? RB. Okay? That is equal to what? Let us transpose this. This will become negative 48 over 30,000. Okay, there you are. Let's have now the second case. Let us draw again the circuit. We have 120 volts. Let us have now the voltmeter across our RB. Our voltmeter reads 48 volts. There you are. Okay? Let us have now the currents. IA. This is I of the voltmeter. This is IB. Okay, by Kirchhoff current law again, the current IA, the current entering at this node is equal to the current leaving. The current entering is IA, the current leaving is IV, then plus IB. Victory and the boy. Okay. What is our IA equal to? Remember, again, just like before, what is the voltage in RA? Of course, that is 120 minus the 48 volts because we have 48 here. We have 120, the total. So, just get the difference. That will be the voltage across our RA. Okay? Are you listening, audience? Please open your camera or else di namin kayo bibigyan ng certificate. As instruction po, pakilagay yung nickname nyo at yung name ng school. Okay, so we have here our IA, the voltage here over the resistance RA. What is our IB? Voltage 48 over the resistance 30,000. What about now for our IB? Remember, they are connected in parallel. So, same voltage, 48 over RD. Now, so we have 120 minus 48. If we are to subtract this, this will give us again 72. So, therefore, we have to put here 72. Okay? That is 72 then over RA. Then, let us transpose this RB. This one. That will become minus. Positive, it will become negative as we transpose. 48 then over RB. So, that will be equal to 48 over 30,000. So, in here, we can have two equations. Equation number 1 and equation number 2. Oh, of course, it's up to you if you want to make it a long method or, of course, in our case, we are using our calculator. Okay? Let us make use of our calculator. Sir, pwede ba yun? Over to RA. Naka-over siya, denominator. Pwede ba yun, sir? Pwede yun. Pwede yun. Okay. We will formulate this as this one. Take a look so that you will know. We have our RA. Remember, I will make this as 48x minus 72y. So that is equal to negative 48 over 30,000. That is our equation number 1. Remember that. What I did is I make x that is equal to 1 over RA. We really need here algebra. Okay? Our y is 1 over RB. Okay? Well, once we get the value of x and y, so just get the reciprocal, and that's it. That is the answer. Okay? What about here? For equation number 2, guys. We have 72. Since this is RA, I will make this as x minus 48y. Then that is equal to 48 over 30,000. That will be our equation number 2. Then, you press your calculator. M is mode 5-1. Okay. Let's press this. Mode 5-1. Come on, guys. Come on. So, we have here 48. Oops. Press first mode 5-1. Then, 48 equals. See, take a look here. And then, negative 72 equals here. And then, we have the constants. Negative 48 over 30,000 equals. Then, let's go to equation number 2. 72 equals. Then, negative 48 equals. And then, 48 over 30,000 equals. Then, press now equals. X here is 1 over 15,000. I will put it in here. 1 over 15,000. Another equals for y also 1 over 15,000. Take a look. This is easy. We just need a tapat-tapat method. What's tapat-tapat method? What is the opposite of 1? Of course, this is 1. This is RA. And ano katapat niya? 15,000. 1:1, RB is 15,000. So therefore, now, we have our RA that is equal to RB that is equal to 15,000 ohms. That is our final answer. The answer would be letter C. Okay? Nakakuha ba mga kawerpa? Okay? Well, it's just, of course, in the manipulation of equation, you have to study your algebra. So this is a third year level. So I suppose you are already finished with your algebra. Okay? You better view my free webinar on calculator math techniques. I already conducted that. That is already being uploaded in my YouTube channel. Please take a look. It's better you go to to Reggie Marinay channel, to my channel, and go to playlist. Go to playlist. I'm wondering if I can show it to them. So, where's my cell phone? It's missing. Okay, anyway, just input my name, no? My name, and then go to the playlist. Then, once you go to the playlist, there is just like a folder, so there is pre-webinar. On the pre-webinar, you press, you will see there the calculator math techniques. I am the lecturer. So, Joshua of UST, Joshua, tumingin ka dun sa aking mga sa YouTube channel ko. Napakarami na akong nai-upload dyan. So, ang nai-upload na namin dyan is, we already uploaded more than 50 videos so far. And thanks be to God. So, we reached the first requirement of YouTube. So, we got already, labang palakpakan dyan. You know, yun, may palakpakan pala doon. Dami nating participants, di ba? So, yun, na-reach na natin yung 1,000 subscriber, no? Medyo matagal, 2.5 months. Sana, no? Sana target natin per month, 1,000 subscriber or more per month. So, I hope you share this, no? To your friends, your classmates, to your workmates, even to your enemies, no? So, you share this knowledge, okay? So, let us have now number 11. Number 11. I want you to watch my video on calculator math techniques. No? Well, to our non-Filipino friends who are watching, we are putting in parentheses my YouTube file, my YouTube videos. So you will see there English and Filipino. But actually it's more of an English language. I use this as a medium of instruction so that you will also understand this. No, just a bit from time to time. I'm using our language, the Filipino language for our hello men, Filipino audience. Okay, let's go over. This is a licensure exam for number 11. A 30 ohm resistor is connected in parallel with variable resistance R. The parallel combination is then connected in series with the 6 ohm resistor and connected across a 120 volt source. Actually, this circuit is what we call the series parallel circuit. Earlier, for number 10, for number 9, we use parallel series circuit. But now, we have series parallel. What's the difference between the two? There is difference. There is difference. I remember the metal and conductor when I teach the electrical principles. No? Not all. Anyway, Let's not make it long. Okay. So, if we mean series parallel, this is the circuit. This is the circuit. Let's say we have a resistor here. Okay, and then we have two resistors in parallel that they are connected in series with a 6 ohm resistor. That is a series parallel. You see the figure. What about, sir, the parallel series? What's the difference? Parallel series. This is the parallel series. That's just like our example before. If we are to take a look at the equivalent circuit, meaning that is the resistance viewed at the source. So, the total resistance here, what is the main connection? What is the main connection? The main connection is we have a parallel circuit. Looking at these 2 points, okay? The main connection is parallel. We have 1, 2 branches. It's just that these 2 resistors are in series. But the main connection is parallel. Where in here, what is the main connection? If you have a total resistance here, the main connection is in series because we can get the equivalent resistance of these 2 resistors. And the 2 resistors, the equivalent resistance is in series with this resistor. The main connection now is in series. Did you get that? Okay, let's continue now. For the problem we have here. Okay, tuloy natin mga ka-aware pa. O, ano given po natin? O, isa-isayin natin, ha? I will solve this in a very detailed manner. So, just please listen carefully. Okay? A 30 ohm resistor is connected in parallel with a variable resistance R. Let's say this is our 30 ohm resistor. There is a variable, meaning there is a resistance unit and an arrow, meaning that is a variable resistor. Just like a rheostat. Okay? But you can vary the resistance. There is R here. Okay? A 30 ohm resistor is connected in parallel with a variable resistance. The parallel combination is then connected in series with a 6 ohm resistor. Connected across 120 volts. Source. Find the minimum value of R. If the power taken by R, you see, there is a statement. The unknown is R. If the power taken by R is equal to the power taken by the 6 ohm resistor, well, remember that this is a total current. That will be our working formula. We have the total current. We have here the current across the resistor. What is the current across the resistor? The current across the resistor by current divider theorem, again, by current divider theorem, that is equal to the total current, IT, then multiplied by what? The opposite resistance, IR. What is the opposite resistance, which is 30? Over 30 plus R. That is the unknown. Okay? So, that is our IR. That is equal to IT. IT, the resultant current, times 30 divided by the sum of the three resistors. Okay? So 30 plus R. What is our PR, by the way? The power here in the rheostat or the variable resistance. That is simply equal to IR squared R. Okay? That is the power in the resistor R. IR squared then multiplied by R. And then that is equal to what? The power in the 6 ohm resistor. What is the power in the 6 ohm resistor? Here, the power here. Well, the current is I total squared. Okay? The power is I squared R. Then multiplied by 6. Now, we have here our IR. Our IR will be I total, okay? And then, multiplied by 30 over 30 plus R. But take note, this is just our IR. IT, 30 over 30 plus R. And then, multiply it by squared. Just make it squared. I mean, what is our R equal to? Anyway, that's the unknown. So that is equal to I total squared. Then we have times 6 here. Let us simplify algebraically. So we have IT, then squared. See? By algebra, this is IT squared. What is 30 squared? 900? Okay. And then, divided by, so put here 30 plus R, quantity squared. Because you have to square all of this. Okay? So, we have here, that's already squared, right? So, we have here R that is equal to IT squared times 6. What will happen, guys, to our IT? So, that will cancel. That will be canceled. Okay? We only have one unknown. Well, anyway, we can shift solve in our calculator, but that will just give you only one value if you will make it a shift solve process in your calculator. But remember, there is a squared here. Therefore, there will be a quadratic equation. So there should be two answers because there is a squared here. Okay? We may replace this one, 30 plus R. We may replace this as R plus 30. Okay? Let us make this as R plus 30. Just the same. Okay, now, this will become 900R. So, that is equal to what? So, we have here 6, and then, let's just cross-multiply the R plus 30 here. Then, we have 6. Let us simplify this further. Well, anyway, we have a 6 here. So, can we have it 900 over 6? Can we do this? Okay. So that this will just become what? R squared. Then this times this, no? R times 30, then times 2. So that will become 30R. So times 2. 30 times 2. Okay. So we have 60R. And then the square of 30. 900. Okay? What is 900 over 6? $150, no? So this is 150. Okay? This is already 150. So we have to make this as r squared, then plus 60r. Let us transpose this. So what is that? Positive, it will become negative. 150 r. And plus 900. That will be equal to 0. So we have here r squared. What about this one? Minus 90, is that correct? 90r, and then plus 900. That is equal to 0. Okay? So, take a look, ha? O, tingin mabuti, ha? Focus mabuti. So, we can make this in our calculator as mode 5.3. Pressure calculator in mode 5.3. Okay, mode 5.3. So, we have here, there is a numerical coefficient of 1. 1 equals, then negative 90 equals, then 900 equals, then equals. Okay, the first value is the first R is 78.54 ohms. And then the second value is 11.46. 11.46 ohm. Remember, this is our X sub 1 and this is our X sub 2 in our calculator. By the way, to our non-Filipino friends, we are using the Casio 570 ES Plus. Okay? You can also make use of 991. Actually, this is 991. Okay? This is 991. The only difference is the this one. Okay, what is our answer, guys? That is 11.46 in our choices. Will be letter. Okay, that is letter C. Okay. Any question? Are there any question? Any question? Actually, that is our last problem. So, thank you. I can sleep now. Okay, sabi ni... Sino ba yan? Is that Mufasa or Simba? Okay. So, any question, mga kawerpa? Baka may mga tanong po kayo dyan. Tapos na po tayo. Tapos na po tayo. Okay? We will continue our lecture on when? Will be MWF starting today. To all our friends, no? O, mga kawerpa, ha? Simula ngayong araw na to, MWF na tayo. Okay? Most probably up to December. Okay? MWF na tayo. Ayan. Pagdating ng January, malamang mag-TTH tayo, no? Pagdating ng January. Okay, so this is a very long study of electrical engineering. Okay? So any question? Are there any question? I am done with my lecture for today. So I will just make it a hinay-hinay. What is hinay-hinay in English? We'll make it a step-by-step process, no? Just relax, okay? Are there any question? I want you to speak in English, no? So let us hear from our friends, our students in our class. Will you show that to them? Pakita nga. Kita natin. O, yan, mga sir, baka may tanong po kayo. O, si Aris. Aris speaks well in English. Can you put out your mask, no? Is it okay? If you don't mind. Okay, Aris. Good day, good morning. In our country now, it's morning, no? Of course, in the other parts of the world, it is evening. It's different. We have different time zones.
Morning.
Do you have any question, Aris?
I don't have any questions, sir. Just
Please speak louder. You're not clear in our studio. In our power room.
I don't have any questions, sir. Only.
You don't have any question? Did you get our lesson for today?
Yeah, I understand the lesson very well. But
Can you comprehend? Any comment?
Yeah, actually, sir, I'm just asking, is it possible to send us,
Pakilakasan.
is it possible to share us the PowerPoint in a soft copy so we can review it also?
What? Hello.
Hello, sir. Hello.
We can't hear you. I'm sorry, we can't hear you.
Can you hear me now, sir?
Yes, it's clear now.
Okay. I just have an inquiry regarding the lessons for today. It was a very, very informative one. So I just want to know if you can share it to us through a soft copy. So at least we can study and see and try to solve it by ourselves.
Okay, this is my honest answer. No, based on not actually my answer only. It's not only my answer. This is the answer of the board of trustees of our company. We are giving this free lecture on air, okay, on YouTube for free, okay. I'm sorry we cannot give the soft copy of our PowerPoint presentation. That's why it is being presented already in YouTube. Well, if you want to get the copy, of course, you watch the video and then you can pause it. You can stop the video, then you can write it down or take. Well, it's easy. Just screenshot. You can have now. That's easy. So I'm sorry that we cannot give this soft copy. It's a confidential file on our part.
Okay, sir. No issue.
Okay, thank you.
We understand it.
Okay. What else? Si Sir Garcia. Sir Garcia, baka may tanong kayo dyan. Ade, alis na yata si Leo. Si Leo muna. Baka aakyat pa ng post ito Leo, you have any question sa lesson natin?
Actually, I don't have any question.
Okay, clear naman sa'yo. Is that clear?
It's clear, sir. It's clear. More for solving problem for today. We have almost 20 questions.
Okay. Thank you. Okay. Sige, wag kayong aalis lahat Usap pa tayo sandali. Sir Garcia, do you have a question in English? Nag-leave na yung iba. So, yung mga nag-leave, I'm sorry, wala kayong certificate. Itong tatlo lang ang i-consider ko. Hindi nila kinompleto po. It's part of the requirement, no? So please complete from start to finish up to the announcements. Okay, so you are in a Zoom class, no? We cannot easily give our certificate to you. Okay, so actually this is, many engineers said that this is too much. This is too much. Giving this free lecture on air. This is too much. But we want to help. But we want to help what do we mean? We want to help, of course, based on what we can at this point in time. But I can say we want to help, but we can't give all. Aris, are you listening? We will give you a portion. Aris, wala na mag-enroll sa amin yan. Hindi na tayo magkikita sa ere pagka lahat ibibigay namin sa ere.
Naka-enroll na ito.
Naintindihan mo ba? Ibig ko sabihin. Yung dalawang engineer na nakausap ko, sabi sa akin, bakit nyo tinuturo yan ng ganyan? wala na kayong wala na kayong makukuhang estudyante kasi lahat binigay nyo na. Ay, mali ka. No? Siguro yung mga engineer na ito, wala nang bala no? Kami, marami kaming bala. No? Okay? Siguro, muna, kung ano yung naibibigay namin sa inyo, let's be contented and be thankful to it. Okay, Aris? So that's what I mean. Okay. Okay, so wag kayong mawawala kasi na tayo, kakat na tayo sa ere. Okay? So to our non-Filipino friends, thank you very much to your we appreciate that. I appreciate. Okay. So we appreciate you. So maraming salamat, no? Thank you very much to all. How I wish you can come into our Zoom. Just take a look at our post. We are posting the Zoom ID on our Facebook account, and that is Marinais Powerhouse. So by the way, I think we can also, because there are so many Filipinos watching us also, hindi muna tayo kakalas. Let's show our marketing presentation. Everybody, please listen. Nandito na. Okay. I-focus na lang natin. Okay na yun, dito na lang. Okay. Focus. Okay, tomorrow, I'm inviting everyone. Everyone. Okay? But I'm sorry to our non-Filipino friends who are watching because this will be in Filipino language. A bit English, there is a combination. It will be a high-rise building, electrical design concept 1. So, on September 1. So, bukas na po ito, mga ka-WERPA. No? So, 9 to 12:30 ulit. Okay? So, andito na po yung Zoom ID. Okay? O, yung ating pong Restudy EE sa RME, ganun din. Ipopost na lang namin po sa Facebook yung ating Zoom ID. Pero itong mga free webinar, ayan na po. Monthly. 8 topic. 8 certificate na libre. E-certificate po ito, no, yung aming binibigay. So, sana magkita tayo bukas. Yung webinar po is advanced topic, no? Advanced topic yan, mga ka-WERPA. Okay? High-rise building, electrical design concept. So, number 2 topic is the Philippine Electrical Code or the National Electrical Code refresher course. Part 3 na po ito, mga ka-WERPA. On September 3, Thursday naman to, Thursday. Tama ba? So, September 3 on Thursday. And then the high-rise building electrical design concept 2 on September 8. Continuation naman to. Kasi bali 4 days namin i-conduct yung high-rise building design. The design concept po muna. There's no calculation for September 1, 8, and 15. But on September 22, there is a lighting and short circuit calculation. So, that is topic number 7. So, every Tuesday is a high-rise building electrical design concept. Every Tuesday for this month of September. So, this is now the details. So, just read. We will post this in our, actually, it's already posted in our Facebook account. The Marinais Powerhouse Facebook account. So, there you are. This is our Facebook account, the Marinais Powerhouse. Okay? So, please, just take a look. Free e-certificate for each topic. Yan, niliwanag ko na, mga ka-WERPA. Okay? Bawat topic, no? Libre certificate. At saka, ang pre-webinar natin, no? Ito yung ating mga pre-webinar. So, karamihan dito naka-taglish. Okay? But, our Restudy EE is, we make it English as our medium of instruction sa ating Restudy. Okay? That is our medium of instruction for the Restudy of electrical engineering. But now, this is different. This is a free webinar. Okay? Via Zoom. Okay? These are the topics already. This is, take a look at our subject matter. These are all the topics that I will discuss to you. Everybody, please listen. This is the topic. I will discuss to you this topic. So more or less, except the power plant engineering, we have a lecture video of our mechanical engineer, He'll be discussing this power plant engineering lecture. Okay, so, and if we still have time, we have a lecture about electronics and communication. Kasi kasama yon sa board exam. No? Hindi lang namin po nilagay dito yon, pero kasama po yon. No? So, MWF na po ang schedule. This is the schedule of study, electrical engineering. This is a very long lecture. Time frame, 2 years. Okay? We are not yet finished to our topic number 2. This is topic number 2. See, subject number 2 is DC circuits. This is a very long topic, DC circuit, because that is a foundation topic. Remember that. And the AC circuits is a foundation topic. These two subjects are very, very important. You need to have a very good foundation to DC and AC, the direct current and alternating current circuits, for you to be able to understand the higher subject, the DC machineries, the AC machineries, even the power systems. You need a strong foundation of the electrical circuits, the AC and DC circuits. Okay? So, MWF, 9 to 12 p.m. Philippine time. Zoom ID will be posted in our FB account. Marina is Powerhouse. The free Master Electrician Fundamental course. It took us so many days to think what is the most appropriate term for this program. Kasi marami nako-confuse. Baka akala nila libreng review ng RNE na yung pinost natin. No? So, hindi po ganon. Ang pinost po namin, pre-review yon. No? Hindi yun yung actual review pa. Iba yung regular review. Iba po yon. May bayad yon mga sir. No? So, mamaya i-discuss ko sa inyo. Ito po, this is a fundamental course. Meaning, we have some subjects. No? It's not a complete subject, but the fundamental subjects here. This is very useful. Okay? To all our currently enrolled electrical engineering student, I am sorry to say that you are not qualified here. To our currently enrolled students, hindi po pwede dito. Dito kayo. Okay? To our electrical engineering students right now, if you are currently enrolled, be here on the study of electrical engineering. But for master electrician, or for our electrician, for our undergraduate or graduate of electrical course, technology, I mean. So, you can avail our free Master Electrician Fundamental course. This is just the same yung aking ina-announce before. Yun din po, pinalitan lang namin yung pangalan because we want to make it more appropriate, more exact. Okay? So, we'll be discussing some technical and Philippine electrical code subjects. No? So, if we have a electricians listening right now, even though you are a high school graduate, no problem. No problem. We will help you. Okay? To reach your dream. Okay? This is somehow an initial review already. This is part of the review. Already part. This is an initial. This is a pre-review program. This is a big help if you will attend. This is just every Sunday, 9 to 12:30. That is one day a week. The rest study is three days a week. So this is 1 day per week only. The Master Electrician Fundamental course. Because Monday to Saturday, they are working in their companies. Free e-certificate. If you are attending the study or Master Electrician, you have free e-certificate at the end of the course. Okay? We will give you one e-certificate. Okay? It depends on your attendance. Per day, attendance is 3 hours per day. On the average, actually 3 hours, we'll make use of that standard. 3 hours per day. For the study, okay, electrical engineering, and for our master electrician, it's 3.5 hours naman, no? For our RME. For those who will avail, this is a very good news to everybody. According to our meeting, this is a very good news. You will have a chance to be a scholar. We will give you scholarship program in our Electrical Engineering and Master Electrician regular review and refresher course. This will start on November. Okay? For April 2021, REE and RNE board examinations. O yan ha, mga kawerpa, magkakaroon kayo ng chance makalibre. 50%, even 100%. It depends on your attendance there. Kung lagi kayong uma-attend, malaki ang chance ninyo, no? Na makalibre kayo sa aming mga ginaganap na ito. Eh, kung perfect ba ang attendance mo, eh, ang laki na ng chance mo. Okay? I-evaluate namin yung participation mo, no? E-registration form will be given once you join in the Zoom. Ayun, no? Ulitin namin yung mayroon lang pong certificate at registration form na titilapan. Yun lamang pong join sa aming Zoom class. We call this as a Zoom class. It's quite sad. Why, sir? Because there are only few students attending to our class. We already experienced 100 participants for pre-webinar. So, I'm encouraging everybody to attend to our study. Anyway, this is just a recording for our YouTube content. But this is better because this is online. Right? This is online. This is much better. Wherein you can ask questions. That is the advantage if you are in the Zoom class. You can ask questions. We can interact each other. Okay? So, I advise you, everyone, no, to all our non-Filipino friends, no, join us in our Zoom class. Okay? All over the world, no? And you may ask question in English. We'll try our best to answer you, to serve you guys, no, for free. There is no payment here. This is for free. We'll give this to you for free. Okay, so we have the Marina's Powerhouse Facebook account and my YouTube channel here. First come, first serve basis. For now, we only have 100 capacity for our Zoom. Okay, how I wish we got the next capacity, which is 500. How I wish we have 500 students all over the world. Huh? And not only 500, if we can make it 10,000 students all over the world, of course, if you have $10 billion, that will start with $1. Okay? Let's start with that. Okay? So we have here special webinars. Special webinar, these are paid webinar already. May bayad na po ito. No? But this is very cheap. No? Napakamura po nitong mga webinar na ito. No? Especially kung estudyante pa kayo o fresh graduate kayo, meron pa kayong 70% discount. No? Nababayaran. We have these 5 topics. Building, wiring, installation. We already have the schedule here. Anyway, please take a look at our Facebook account for the details. Building, wiring, industrial motor control. Okay, kung nag-avail kayo, na-postpone namin yung August kasi medyo konti pa yung nag-enroll, dagdagan lang natin ng konti. Huwag kayong mag-alala, marami konti, tuloy natin yung program. No? So, electrical estimation. Okay? So, this is a very nice topic, a very practical topic. I will make it live. Lecture. Although we already uploaded one of my lecture in electrical estimation. But this is much better now. I can assure you. I already gained additional experience in estimation. I can share that with you guys. If you want to avail, no, then electrical design. We will start this Sunday. Electrical design. This Saturday, by the way, meron tayong building wiring and the power system engineering course. Tingnan nyo na lang po, napakamura lang mga kawerpa, 1,500. But wait, there's more. If you are electrical engineering or technology student, 70% discount. The 1,500 will become 450 pieces. Okay. Di ba? So, napakamura po nito. No? Ito po'y dati, mamahal po ng presyo namin yan. Mababa na po 3,000 yan dati sa aming face-to-face class. Bibigay lang po namin ng ganyan kamurang presyo. At tapos sa estudyante, grabe, no? 450 pesos. Eh kung ang i-avail mo, itong ilang oras to? 1, 2, 3, 4. 16 hours itong power system engineering. Tsaka yung electrical design. 16 hours for 450 pesos. How much is that in per hour? Mode 1. So that is 450 pesos. I'm just wondering, no? Because I saw a training center, his charges per hour basis. He's charging 1,000 per hour. Or I saw 200, 500 per hour. We only have 450 pesos for student, no? For 16 hours. Wow, that is only 28 pesos. That's very cheap. That is just half a dollar. Okay? What do you mean half a dollar? What's the unit of that? That is less than $1. In our country, $1 is around 50 pesos. That's the conversion. So, everybody, baka gusto po nyo mag-avail, yung mga nanonood sa atin sa YouTube Live, connected po sa Facebook, direct connected kayo sa YouTube live stream namin, baka gusto nyo po mag-avail ng aming special webinar. Andyan na po yung ating pong course outline. Ito yata hindi pa natin na-i-post, no? Kompleto na po yung aming course outline kasi may mga nagtatanong, no? Sir, ano ba yung mga topic na i-discuss ninyo dyan? Ayan po, no? Hindi ko na po maisa-isa lahat. Ipo-post na lang po namin sa aming Facebook account, no? So, ito po yung mga special webinar, no? Ito yung mga paid webinar. 70% for our electrical students. Okay? Mura pa rin kahit professional na kayo, matagal na kayong graduate, napakamura pa rin, 1.5, no? Sobrang mura niyan kumpara sa inyong matututunan, no? Okay? Then motor controls, I will have additional topic about the variable frequency drive and an introduction to a programmable logic controller. Although the focus is electromechanical controllers, no? This is an introductory course. This is leading to test the EIM NC3 if you want to take the certification exam of TESDA, no? Okay, industrial motor control. This is our actual class. You see, this is me, the one in the middle. Yeah, that is our actual class. But to be honest, this is just an online training. We can't make it on face-to-face basis. It's because of the danger of COVID in our places, no? So we better have it via Zoom. Yun na lang ang ating magagawa muna ngayon. Okay, kaya ganun din kamura yung aming ino-offer kasi hindi pa natin magawa yung face-to-face na yan, no? Okay, so we have the practical electrical estimation course. Ayan na po yung mga topics na i-discuss ko, no? Material costing, labor costing, material take-off. Okay, paano ka ba magbigay ng total offer price kung lalaban ka sa bidding? Kasama na po yan. Preparation of proposal na wala yung letter. Proposal letter yan. Okay. So, ito naman po yung ating electrical design course, no? Based on the Philippine Electrical Code. No? By the way, to our non-Filipino friends, no, who are watching, our Philippine Electrical Code is somehow similar to the National Electrical Code of US. So, it's just a little conversion, a little difference, no? Okay. It's our electrical design course, no? We'll also discuss the voltage drop and short circuit calculation aside from the sizing of the branch circuit, feeder, and sub-feeders. Okay, so if you want to become proficient in this topic, the design course, very important. And we have the power system engineering course. This is the high voltage engineering course, no? To our professional, baka gusto nyo mag-refresh, no? Yan na po yung mga topic, very nice topic. Then isasama na rin natin ang fundamentals ng protective relaying and load flow analysis. Kasama na rin natin yan, mga kawerta. Then may halo pa pong power factor correction yan, no? Okay. And to our early bird promo, okay, hanggang September 3, meron kaming extension. Sa REE po, 9,000 lang po ang review and refresher namin. 9,000 pesos. Kung ika-cash ninyo. Pag installment, magiging 11,000 po. Plus 2,000 ang madadagdag. No? Kailangan mo lang magbayad ng 2,500 on or before September 3, then yung balance mo sa day 1 na lang. No? Pero kung cash, 9,000. Ika-cash mo yan, ulitin ko. Yung 9,000, dapat bayaran mo in full sa September 3. Kasi nga, ito ay early bird promo. No? Kung hindi, ulit ito. Tingnan mo. Sino ba to? Timo Pasa. Okay. Sige. Ayun ha, mga ka-aware pa. Ang kagandahan pa nito, 100% discount on second online review course when you fail the board exam. No? Pag bumagsak ka, no? 100% discount ka na sa susunod mo na review course. As in, wala ka nang babayaran. Libre na ang next review course mo. Okay? Review course mo, libre na pag bumagsak ka sa board exam. Wag naman sana, no? This is just like an insurance. Parang ano lang namin sa inyo na seryoso talaga kami. Not to serve you. Para masabi namin sa inyo how we are serious to serve all of you guys. No? Okay? This is the best online review setup among others. There. Ulitin ko po. There po. This is our challenge to our colleague in the review center industry. Gayahin niyo po yung setup namin. Kasi ito ang pinaka magandang setup. Hindi yung ano lang, boses lang na. Iba-iba na yung nakita natin eh. Ang dami na po eh. Boses lang nakikita. Meron naman yung teacher. Kung ito yung PowerPoint, nandyan lang siya. No? Ganun lang yung nakikita natin. No? Hindi ganoon ka, ano ba, katulad nung ginagawa natin. This is the big difference. You will feel that you are in a classroom talaga. Kahit na layo-layo tayo, wala pa pong nakakagawa nito hanggang ngayon. Although may mga sablay po kami, mga sir, no? May mga sablay kami, no? Sa mga signal, sa ano, hindi na namin kasalanan yung sa signal, no? Sa ano na yon, okay? Sa nirerentahan natin yon. But what I mean, yung setup na ginawa po namin, I never saw since we started last June up to last night. Araw-araw po akong nagtitingin ng ganitong setup. Wala pa po sa YouTube ng ganitong setup. Even in America, the richest country, they say, no? There's no setup like this. Okay? Interactive. This is a virtual classroom. Okay? So, I'm inviting everyone to attend to our Zoom class. Okay, so we are on sale of our REE books. Okay, for those who would like to avail to our review materials, Master Electrician, and Master Plumber review books. Please subscribe, no? Like, comment, and share to our YouTube channel. No? Okay, ako lang ang nakapangalan, pero this is our YouTube channel. Ito ang YouTube channel ng mga Pinoy electrical engineer and electrician, master electrician. No, ito ang ating YouTube channel, mga kawerta. No? So, the Reggie Marina YouTube channel, no? Study Electrical Engineering the Filipino way. Okay? So, for those who are interested to us, so please you may message us to our messenger account or to our Facebook account, the Marina's Powerhouse Facebook account. Okay? Just wait for our website. No? We are doing that. We are doing that. We are preparing so that we can have a website, no, to serve you better. Okay? So, please wait for that, guys. Okay, that's it for today, and thank you very much to everybody. Thank you, guys. God bless you all. Stay safe. Thank you.